Hello friends, today we have the topic about the compressed air validation and distribution system qualification. Okay, so our aim to qualify the compressed air is the compressed air generation system and distribution system should be designed in accordance with the GMP. Okay, that is called the design qualification also. So this is verified in design qualification, and compressed air generation system and distribution have built and installed in compliance with the design specification. That is our aim to qualify that, and that is called the IQ. And compressed air generation system have to be operated in accordance with the design specification, functional specification, design functional specification, that is called the OQ, and a specific process that will consistently produce a product meeting its predetermined specification and quality attributes, that is PQ. Means what is our requirement specification for the compressed air generation system, that will be our PQ. We have to qualify our system in accordance with the user requirement specification. So our system have a design operated and built and qualify as per our user requirement specification. So it will meet the user requirement specification. We have the three stages for the compressed air life cycle as per the US FDA guidelines for the life cycle approach. Stage 1, stage 2, and stage 3. Stage 1 is that we have to define the design of compressed air system. It includes the user requirement specification. We have to define the user requirement specification and functional requirement specification. Then the vendor will provide you design specification, functional design specification, and we have to review our design document, that is called the design qualification. After approval of the design, the stage 2 will be begin. Stage 2, after fabrications of the system is transported to the vendor side or customer side, and then it will be evaluated. The evaluation of design to determine the compressed air generation system and distribution system is performing as intended or not. So this stage required three qualification criteria, that is installation qualification, operation qualification, and performance qualification. So all three stages should be meet as per the design specification and user requirement specification. Then we can see, yes, our system is evaluated and the design is compliance to the user requirement specification. Then uh, forward to the third stage. This is the ongoing assurance of the compressed air system, that it will remain in the state of control. So for that we are using dual calibrations, all the components of the compressed air system, that the dual calibration stable calibration, preventive maintenance schedule. Okay, the review of deviation and breakdown with respect to the compressed air system, any deviation in past 1 year or 6 months, quarterly review of the deviations, breakdown specifically for the compressed air system. And then schedule requalification after 6 months or 1 year as per the company policy, that should be periodically qualify, and it should be uh, once in a year. That is the minimum requirement. This is the B model of qualification. So for compressed air, we are discussing about the B model. First of all, we have to prepare the user requirement specification. What is the use of that compressed air? Why we are procuring that compressed air system? That is the main important thing. So this is the user requirement specification, where we have to define all the requirements. What is the pressure of the compressed air? What is the quality we required? Which class we required for the compressed air? Where we are going to use that compressed air? So that is the user requirement specification. Then functional design and detailed design. Functional design means it consists all the requirements, all the parameters for the operation of the equipments or compressed air system. And detailed design, what are the instrument, that is or components, that is make, model, and other specification that include in the detailed design. Okay, and then implementations means the after the approval of the design, the fabricator or the vendor will start the compilations or fabrication of the equipment. Then it will ship to the uh, vendor side or customer side for the installation qualification. So installation qualification, basically that the IQ test plan that is should be uh, compiled or counterpart of the design specification, detailed design specification, make, model, suppose what is the make of model, what is the make of compressor, what is the serial number, everything that is the IQ test plan that should be same as per the design specification. And then operation qualification, after successful of installation qualification, we hand over the system for the operation qualification. In operation qualification, all the test plan should meet the functional design. What is our functional design, what is the parameter inside the functional design, the vendor mentioned, and we have approved that design, same should be meet in the operation qualification. Then come to the performance qualification. Performance qualification, that is the counterpart of the user requirement specification. What is our requirement, like how much pressure we require, what is the quality of air. ISO 8573 is the guideline for the quality of the compressed air. So what class of compressed air we required, what is the level of moisture, what is the level of dew point, what is the level of oil mist, what is the level of particle counts that which should be made in the uh, compressed air. So that should be qualify in the PQ test plan. So user requirement specification that should uh, challenge in the performance qualification, and performance qualification is the counterpart of user requirement specification. So now you understanding the importance of B model, and this way all the equipment qualification is going on this way. Now we will discuss about the user requirement and functional requirement specification. A requirement specification that describe what the compressed air generation system is supposed to perform, okay, and thus containing a list of set of criteria and conditions that have to be met. Okay, what is the quality of compressed air that we required? So URS, minimum requirement of URS that should be in your URS, like technical requirement, functional requirement, software control and monitoring system, like you want to SCADA, PLC, HMI. Okay, what are the controls you required? Performance requirement, which type of compressed air required, what's the dew point of compressed air. Okay, product specific requirement, if you required any this compressed air that will be directly exposed to the uh, product. So what is the product specific requirement? What is the level of moistures you required? Okay, what is the dew point, -60, -40 or -80 you required? Okay, what is the particle count limit? Which class of 0, 1, 2, 3, which class of compressed air you require? That should be product specific. If there is any product specific requirement, that should be mentioned. Security requirements, what is the interlock is there? Okay, overloading compressor interlock. Okay, and unloading compressor interlock, what is the maximum pressure interlock, minimum pressure interlock, safety feature, that should be security requirement. And also safety interlocks. Okay, then process interlock, if there is any dew point, like process interlock means if there is a increased amount of humidity or malfunctioning of a dryer or compressed air generation system, dew point increase, then it should be automatically drain off all the air that should not go inside the process area. So that is also process interlock. If there is any process interlock is required, then you have to go for the process interlock. Alarm, which type of alarm you want to display on the HMI. Okay, indication, which type of indication you required, alarm with the hooter or any lamps, like RVY. Okay, which type of indication you required. Control panel, where you want to install the control panel, how many control panel you required, like back side, front side. Okay, which type of control panel you required. Then report requirement, which type of report it should be generated through the SCADA or HMI, or what the parameter should be captured in the report, that should be defined in the user requirement specification. Then accordingly your vendor will be configure your HMI or PLC so that this parameter can be captured. Okay, then 21 CFR UNX compliance requirement with respect to the security, user authentications. Okay, passport policies, everything that you have to mention in your user requirement specification if you are going to 21 CFR Part 11 compliance system. Then utility requirement. What are the utility requirement for that system? What is the electricity requirement? What is the chiller or any other requirement you required for this system? So that should also be mentioned. Scope of supply, that is main important things. So there should be no ambiguity in the scope of supply. What the customer will provide, what the vendor will provide, that should be clearly mentioned. Means the company and the vendor, what are they providing, like electricity arrangement, cable arrangement, or what are the scope of supply, which document they provided. Everything should be mentioned in the scope of supply. Then time frame, that is also important. 6 month, 3 month, 2 month, when the from the design specification to the performance qualification or handover, what is the time frame there, and what is the time slotted for each and every stage of the qualification, that should be mentioned in the time frame. Then material of construction and finishing, which type of material of construction you required, which type of finishing you required, because all these are cost if, that will be cost effective. So which type of material and construction finishing, that will all be impact on the cost. So you have to mention clearly which type of construction or material and finishing you required. Also the material for construction and finishing for the compressed air system, that should be clearly mentioned to meet the GMP requirements. Okay, it should not erosion, there should be no rusting like that. You have to mention everything, which type of material you required, SS, MS, okay, which grade of SS you required. Then environmental condition, where you are going to install your compressed air system, that main important, the environmental condition. If you are design your compressed air system at a humidity 40% or 30% in that area, and some area having, suppose you are going to install your compressed air system, your company in the tropical area where the humidity is 80 to 90%, then there is a difference, huge difference in the design. Okay, so environmental condition, temperature and humidity, that should be mentioned in the URS. What is your environmental condition at the service floor or where you are going to install that air compressor. Then document requirement from the vendor, which document you required, like design qualification, FAT report, SAT report, okay, material of construction report, okay, motor certificate, calibration certificate of the instruments, everything, what the document, P and ID diagram, pneumatic diagram, GA diagram, everything you have to mention in your URS, so that vendor will provide all these documents. Then initial risk assessment. After the URS, you have to initiate the initial risk assessment. That is the qualitative approach. Two type of approach is there. One is the quantitative approach. One is the qualitative approach. So a clear understanding of the system and the role it plays required in the established protecting the process and quality. So all of the potential way of the risk of process quality can be impacted by the failure, events, error, or time used based on the factor. So you have to keep all these things in the mind and do the initial risk assessment. Define all the design, procedural and quality control system required to protect against these potential risks. These are the control either mitigate or reduce. So you have to challenge your system, your procedure against the each of the risk. Then you have to identify what are the major risk in this process and what is our control. If you don't have the control, then you have to put the controls, or you have to write the strategy to mitigate that plan. Somehow you are going to challenge in the qualification, you are putting some procedural or system control to reduce or mitigate that risk. Okay, compile the evidence during the design, engineering and commissioning and qualification to demonstrate all these required control have been properly implemented, including the function where applicable, such as the alarms or operating system. Suppose there is a risk with the compressed air system, high dew point. Okay, the dew point is out of limit, like you have the limit minus 40 degrees Celsius, then it will goes to the like minus 30, minus 20. Okay, so you your air dryer may be tripped. Okay, due to some reason air dryer is tripped and your dew point is going higher side. So what is your control? This is the risk to the process. okay, and the water is going inside the pipelines and that will be contaminate the product. Okay, so that is the risk. Now what is your control? Yeah, in your design specification or in URS you have mentioned this requirement that you required alarm system, you required dew point indications, you have the dumping process. So that should be challenged in the either IQ or OQ or PQ. You have to challenge these implementations. Suppose you are saying yes, we have this procedure. So where you challenge this procedure. So that is very important. Okay, so every risk you are identified here and every control you mention here to mitigate that risk. Okay, so that control should be challenged in the design, engineering, commissioning and qualification. Okay, so initial risk assessment, we have the three criteria: qualitative approach. One is the quantitative approach and one is the qualitative. When we have the new system, we go for the qualitative approach. Okay, so we have the high, low, medium, severity and probability also low, medium, high. Okay, so first of all, we have to identify the risk priority, risk classification, risk priority that we have to identify. So if we have the high severity and low probability, then it will go to the risk classification, go to the level 2. Okay, yellow color shows the level 2. If we have the severity high and probability of occurrence medium, okay, we don't have such controls. We have the systematic control but we don't procedural control, but we don't have the systematic control autonomous system, okay, to detect the failure. So occurrence may be, probability of occurrence may be increase. Okay, we have the procedural but we don't have the automated or system control. So the occurrence may be medium. So high severity and medium, that will go to the level 3. So this way we have to, first of all we have to calculate the risk classification. This is the risk classification. Now level 1, level 2 and level 3. Level 3 high, level 2 medium and level 1 is low. So when we have the risk classification, now we have to find out the probability of detection. What is our control? This is comes on from the control, that what is our control. If we have the good control automated system, then the probability of detection high. If we have the medium procedural control, then we have the medium probability. If we don't have any procedural or systematic control, autonomous control, then the probability of detection will be low. So for this purpose we have to multiply this. Like suppose a risk classification, from this we got the risk classification level. So level 3 means high risk classification. If we have the probability of detection high, then it will go to medium priority. Okay, if it is medium, then it will go to the high priority. If we have the level 1 low severity, then it will go to the low priority. Okay, so from this table we got the risk priority. Now what we do with the risk priority? This is the verification method for the risk mitigation. Now we have the priority, low, medium, high, and now we have the component system functional assessment. For this we have to do the component assessment. Which component is critical, which component is a major, which component is minor, and which component is a cosmetic or operator enhancement. That is the component criticality assessment, CCA. That is called the component criticality assessment. That document also to be prepared along with this risk assessment. So what is the critical components that should be mentioned in your design specification or in design qualification? You can mention the requirement for this also from the vendor in your user requirement specification. Then they will provide you which component is critical, major, minor or cosmetic. Okay, so once you have the component list, then this will be go the risk priority. Suppose dew point meter, that is the critical component. Okay, now low priority, high priority and high low, medium and high priority. If it is like critical component, if it is low priority, then it will verify directly. If it is medium priority, then verify directly, and risk mitigation plan should be there. You have to challenge that requirement, that component. You have to challenge that procedure. You have to challenge that system. You have to challenge that is in place and functional. So this is the risk priority, and we have to prioritize our risk assessment accordingly. We have to put these tests in the your qualification IQ, OQ, PQ, so that we can directly verify and uh, we have the some mitigation plan for that. Okay, so this way we have to do the initial risk assessment. From here we have to make some challenge test in the qualification. Now IA means impact assessment. When we have procure new system, suppose compressed air generation system and distribution system, we are going to procure. So what is the impact on the uh, uh, already that installed facility, or what is the impact on the other things? Suppose you have already a compressed air system, now you are going to upgrade your compressed air system. So what is the impact on the design, user requirement specification, okay, or other documents? Suppose you have already distribution system in place and you are going to upgrade your compressed air system, generation system or dryer. So what is the impact on that user requirement? So for that you have to do the enhanced design review and prepare the new user requirement specification and enhance like design qualification also. Then perform the impact assessment on the modification changes done in the compressed air distribution system. What is the impact on SOP? What is the impact on qualification protocols? What is the impact on other area? What is the impact on the process? So all impact you have to assess. That is called the impact assessment. Now functional design or design specification. This is the other documents that vendor will provide you, the design specification. So design qualification of compressed air generation system and distribution system is planned systematically, reviewed to evaluate the design deliverable against the requirement. So what we do in the design qualification, we just review the design, what the user requirement specification we submitted to the vendor and what they provided us. So we have to do, review the design. Enhanced design review means you have to conducted in case of equipment is already in use and some of the upgradation you have to do or near location for the any specific project. Then you go for the enhanced design review and assess the improvement or changes required in the design qualification. That is called the enhanced design review. Then functional designs and design specification, functional specification and design specification, the process applications, compressed air system should be included a supply side and demand side. So your design should consider for compressed air. If we are talking about the particularly compressed air system, there are two parts. One is the supply side, one is the demand side. Demand side means distribution system, and supply side that include the generation system, your air compressor, filter, air compressors, dryer, and then filters, and then storage. That is called the generation system. So from design supply side, we have air compressor, filtration, air receiver, dryer, and control system, the PLC control system or automatic control system. That is all the supply side. Okay, so design of the supply side compressed air system, specifically for the air compressor, we discuss here air compressor, that is post-tip displacement. Okay, post-tip displacement, air secures or mechanically reduced to generate the pressure. Reciprocating compressor or piston type air compressor, oil free rotatory screw type air compressor, and oil injected rotatory screw type air compressor are the example of positive displacement type of air compressor. Dynamic include the velocity using the impellers and then convert air motion into the pressure. This is called the dynamic type of air compressor. So most of we are using oil free rotatory screw type of air compressor. Okay, then this is the positive displacement air compressor. The air secures mechanically and reduced to generate the pressure. So oil lubricated injected rotatory type of air compressor is this type. Okay, you see in the facility, this is called the positive displacement air compressor. Then Again, oil-free rotatory air type compressor. This is the graphical representation of the oil compressor. Then centrifugal air compressor, that is called the dynamic that produce oil free air. Okay, it does not use any lubrication or oil, so it includes the velocity using the impeller. It sucks the air by the impeller and then convert that air motion into the air pressure. Then air treatment. So what are the air treatment we are giving to the compressed air that is sucked from the environment? So first of all, we have the air compressor cooler, because whenever we have compressed air, that the temperature of that compressed air will be increased. So compressor after air cooler, filtration, separator, air dryer, air receiver, traps, and automatic drains. These are the some components that required for the air treatments. Filter to separate the dust and oil. Okay, separate that, remove the oils or lubricant from the air. Okay, and also water from the air. Then dryer will dry the air. Okay, that reduce the moisture from the air or water vapors from the air. Then air receiver will receive the air, hold the act as a buffer tank for the supply demand side. Okay, then traps. The traps are the basically used for the trapping the oil or water if there is any in the stream. Then automatically drain, that will be provided at the bottom of the storage tank. So it will automatically drain the if there is any moisture trapped in that bottom. Okay, so that will be automatically drain. Now this is the air quality parameter as per ISO 8573. There is a air quality parameters. Okay, so there is a different classification of the air. Accordingly, we have the um, limits for the parameters like particulate matter, water, pressure, and oil and vapor. So if we are using class 1, class 2 air, okay, the dew point is goes to -100 or -40, -4 Fahrenheit, okay, or -70 degree, -40 degree, or -20 degree. Okay, then +3, +7, and +10. So these are the classification of air. Similarly, oil and what vapors, oil vapors, that is less than 0.001, 0.01, 0.1, then 1, 5, and more than 5. Okay, these are the parameter for the oil and mist. So accordingly, what are our requirements for the compressed air, where we are using? So accordingly, we have to mention in our URS which type of class of air you are required. Then vendor will provide the appropriate control for the quality of the air. Okay, similarly for the 0.1 to 5 micron, zero point 0.5 micron, zero point 0.5 to 1 micron, and 1 micron to 5 micron, there is a for class 1, class 2, class 3, there is a different criteria for the particle counts. Okay, then come to the air dryer. Air dryer also be a part of generation system. So regenerative, heat of compression dryer, and refrigerator dryer. These are the three type of dryer that we are using. Regenerative air dryer, desiccant type, silica gel, activated charcoal, or molecular sieve. These are the regenerative air dryer. Why we are called this regenerative dryer? Because they require the regeneration simultaneously. One tower is working, one tower is standby, that is regenerated, and when this is the, another tower is regenerated, one is producing the dry air, then it will switch to other tower. So two tower is basically working on the one time. One tower is working in the one time, second is on regeneration. Okay, first one in use, second one in regeneration. Heat of compression, that single basin or twin tower dryer, that will require the heat for the drying of the air, for the removal of the moisture, that require the more heat like 300 degrees Celsius. So these are the heat of compression dryer. And refrigerated dryer, that are the simple dryer that use the refrigerant gas, that when it comes like fins or coils of the that refrigerant is coming in contact with the air, that will remove the moisture from the air, that in the form of condensation. So condensation will happen and the air will get the dry. Okay, so now we will discuss one by one. This is the regenerative dryer, that is the desiccant type silica gel, activated charcoal or molecular sieve. So these are the towers, these are the twin towers. Suppose this is the desiccant type silica gel or activated charcoal. This one tower will be working and one is the on the regeneration. So here is the control system that will switch off. You can set the time based on the qualification criteria. You have to make the strategy for the qualify this time. So 5 minute, if 10 minute, they will switch when it is on use. So this will be regenerated. So how it will be regenerated? Because this air, suppose air is going like this, okay, and then go to the receiver. So here small amount of this dry air will go in this chamber and then it will be exhaust from here. Okay, so the moisture that is in this activated charcoal or silica gel, that will be get dried off with this air, because the air will get humid and then expel from this air. Okay, so it will get dry until it is used, then it will switch to this, then air will be going this side, and then the air, small amount of air will be using regeneration of this, then it will be exhausted. So this way, 5 minutes this, 5 minutes this, there will be alternative working. So these are called the regenerative air dryer. Then come to the heating side. So heat of compression dryer, that is the single vessel or twin tower that use the high energy for the heating of the compressed air. First they will heat up the air to dry the moisture or remove the moisture from the compressed air. Okay, so this can be used for the removal of the moisture. This is the refrigerant air dryer, type of air dryer that use the uh, refrigerant gas. Okay, when the gas is comes in the contact with the these tubes or fins from the then it will condensate. If they have the moisture, they will condensate. So each and every having their limitations and advantage. So heatless air dryer initial cost is low, but it will use the purge air. Purge air means that use for the regeneration. So energy cost will be high, and the dew point can be possible -40 Fahrenheit to -100 Fahrenheit, means -40 degree to -70 degree Celsius. It can be possible through this heatless air dry. Extremely heat is means above 300 degrees Celsius. It is initial cost is medium, and 7 to 8% it is energy and cost effective. Okay, so it is medium. It can be maintained the -40 to -100 degrees Celsius. Blow purge, that is the initial cost is medium, and similar to the 0 to 3% is the energy cost, energy efficient. So it can maintain the dew point up to -40, up to -40. Then heat of compression drum type, this is the initial cost is high, but it is the energy cost effective. There is no loss of the purge air or air. Okay, so it can maintain the dew point 0 to -20 Fahrenheit only. Okay, 0 to -20 Fahrenheit is can be used. If we are using the compressed air, we require the compressed air that required the dew point -40 Fahrenheit or -100 Fahrenheit, then it cannot be used in that case. Okay, so you should clearly mention in your user requirement specification which type of air you require, what is the class of air. Okay, heat of compression twin tower, that is the initial cost is high, and 0 to 2% that is required, but it is energy cost saving, and it can maintain less than -20 Fahrenheit. Okay, so this is the advantage and disadvantage of the different type of compressed dryers that we are using for the generation system. Now the filtration process. So to remove the dust and other oil droplets or water from the compressed air system, that we are using 1 to 3 microns particulate filter, high temperature particulate filter, that is used for the minus 176.7 to 232.2 degrees Celsius. These are called the high temperature particulate air filter. Okay, Coalescence filter, that oil droplets 0.01 micron, 0.01 micron removal capacity. Okay, up to 0.001 ppm it can be removed from the stream. Okay, then final filtration is zero point 0.2 micron. So these are the filter that we can use in the compressed air system. Okay, now on the demand side, we have the on the demand side there is a air distribution system and pipeline terminal filter zero point 0.2 micron. That is the demand side. So your user requirement specification should mention how much points is there, which type of compression, which terminal filter you required, how many points in the distribution system, what is the type of machine that you going to use, what is the CFM that you are required to use in the each and every machine. So then you can calculate, or vendor can calculate the capacity of the compressed air system. Okay, if you require that 1000 CFM compressed air system, and the vendors design the 50 CFM compression system, then it will no use. So you have to clearly mention how many points, user point, you are going to you required for the compressed air system, and what is the uh, demand at that point, what is the pressure you require, what is the CFM that consumed through the machine. So that all should be defined in your user requirement specification. Now come to the factory acceptance test. Factory acceptance test, that is the the test parameter to challenge whether our system or design as per our user requirement specification before shipment from the vendor side. So this factory acceptance test is done at the vendor side. The vendor is called to the company representative that our system is ready, and you can challenge or test that system at the vendor side. If there is any recommendation, any gap you have identified from the user requirement specification or design specification, or any additional requirement is there, then you have to go for the MOM, or you raise the requirements, and then they will implement it before the shipment of the equipments. So the objective of the factory acceptance test is to verify that main item of the system meets the design specification and confirm to agree the performance intent. The factory acceptance test is carried out prior to installation, before shipment to the customer side, that will be done. Okay, and to demonstrate that fabricated compressed air system are confirmed to comply the URS FRS as the vendor side. So as I told you that this is done at the vendor side. This is the mandatory for the like most critical or critical equipments or direct impacting system. You have to challenge the system at the vendor side. So you have to go for the factory acceptance test, company representative, QA, engineering, production, operator, that will go form a team, and that they will go to the vendor side with the protocol, either protocol provided by the company or by the vendor, that is the mutually agreement, and then you go for the test of the as per the protocol. If required, you have to ship the material. If in case of equipment, then you can also ship the material to the vendor, raw material, or any other packing material which you are going to procure the machine, suppose compression machine or any other critical machine. Then you can challenge with those all these tests like IQ, OQ, PQ, that commonly we are going to perform in the factory acceptance test in the same protocol, so we get the idea how the machine will work. Set site acceptance test, that is the uh, uh, that is the test parameter or qualification parameter that we are going to do at the customer site or in the company site where the actual equipment is to be installed. Okay, and this will be done before the installation qualification. This is main objective of the site is to establish the document evidence that the receipt of item at the site confirm the laydown standards as per the protocol. Means physical visual verification of the machine, physical installation of the machine, required utility provision, all the utility is qualified and there is a provision for the utility, appropriate human interface that should be installed properly, physical safety environment where we are going to install that equipment. Okay, availability of the documents like user requirement specification, manual, P&ID, FAT punch list verification. Means uh, the FAT that we have performed, if there is any recommendation, any shortcoming is identified during the FAT, and we have to make the MOM, that is called the FAT punch list. So before going the installation qualification, what is our recommendation that will be verified in the SAT? Okay, this can be clubbed with the installation qualification. So some companies is performing SAT, and some companies is included this test in the installation qualification. So there is no issue, you can club both activity together, but it is better to go for the SAT also if you have the like fat punch list, or you will not go for the further delay of the activities due to the some shortcoming in the system. Okay, or you identified this is not done in the later stage, so you have to verify all these requirement in the SAT. Then RTM, user requirement traceability matrix. Suppose you have to purchase the system as per the URS design qualification, you have verified, you have done all these tests, IQ, OQ, PQ, and lastly, how you will identify user your requirement specification is meet the design or meet the equipment that you are installed in the facility. So for that purpose, we are prepared a user requirement specification or requirement traceability matrix. Okay, the purpose of this traceability matrix is to ensure that requirement mentioned in the user requirement specification has been covered in the design stage, test and verified to meet the intended parameter. Okay, and the parameter to be mentioned as per the URS and assurance in the DQ, and testing at the further stage to be traced by the placing the reference point of the respective qualification document. Suppose you have the URS, now you are going to prepare the RTM. So you mention all the test criteria, all the requirement in your RTM section by. Suppose there is a dew point should be -40. Okay, in which section you are mentioning in the user requirement specification, that section you mention in the RTM, and then and also in the DQ where it is mentioned vendor, this is the requirement that mention the section and URS section and DQ section. Then you take the printout, approve the requirement traceability matrix, then start the filling. Okay, where you are going to verify this is the requirement. So in IQ, OQ, PQ, where you verified this parameter. Okay, suppose the system should have the 3 level of access like user, operator, manager or supervisor. Okay, or operator, supervisor or manager, there is 3 level of password. So where you are identified that part, where you challenge this part, suppose 6.1 in operation qualification under the security, this is the section number 6.1, security verification or verification of password. This is mentioned in this. So you have to mention the section number in against the stage like OQ 6.1 we have done this test. Okay, 12.3 section we have done this test. Okay, then IQ, OQ, PQ. After the PQ, all the tests should be complies. Okay, all the requirements should be complies. Then you realize that, oh yeah, my URS will be complies with the design. Okay, the equipment that we have to procure that meet our user requirement specification. And this is also serve as a checklist when the auditor asks which test you perform in which section, or this test show me, then you can open this user requirement specification and then you will show directly that part. Here we have to challenge this test. This is called the user requirement specification. SIA, system impact assessment. Now when you have the system, you procure the system, you have to categorize your system, whether it is the direct impacting system, non-impacting system, or indirect impacted system. Okay, and what is the qualification approach you have to apply for the, like suppose commissioning and installation and operation, or full scale IQ, QPQ, what the approach you are going to apply for the system. So you have to do the system impact assessment. So for system impact assessment, you have on this is the diagram representation how you will do the system impact assessment. First of all, you have to identify the system. Suppose compressed air system, identify the system boundaries. Okay, what is the where we are going to use this system. Okay, it is with the direct product contact, non direct product contact, where we are going to install, what is the purpose. This is the system boundaries. Now, does the system have the direct impact on the product quality? If yes, then it is the direct impact system. If it is no, then move to the next question. Is the system uh, linked to the direct impact system? Suppose, for example, if it is a compressed air system, if it is comes the direct product contact, okay, for purging, or suppose coating of the tablets, we are using the compressed air as a automation air, okay, or for purging in the RMG or granulation area, okay, then it will goes to the direct product contact, then it will be a direct impact system. Suppose you have the small air compressor that is required for the nitrogen gas generator, and that nitrogen gas will be direct in contact with the product, then it will be going to the indirect impact system. Okay, try to understand. Direct impact system which have the direct link to the product quality with the product, okay, then it will be a direct impact. If it is linked with the direct impact system, then it will be indirect system, okay. And then no impact system, if there is no direct impact or indirect impact, then it will be go for the non-impact system. Suppose AHU that you are using for the office purpose, okay, for the conditioning or making the comfort in the office, okay, so that will be no impact on the product quality. But the issue that is installed in the granulation area or anywhere where we required the air classified area, okay, that will impact the on the product quality, that will be a direct impact system, okay. Then you have to develop the supporting rationale for the qualification of the system. Now, which approach you are going to apply? Suppose it is no impact system, then you go for the simply for the asset number and commissioning report, that is sufficient. No need to do the calibrations of the components and everything, okay. Then no need to develop such type of. If it is direct indirect impact system, then what will be approach will you apply? Suppose if it is indirect system, then you can go also IQ, but it's depend upon the criticality, so you can also do for the PQ, okay. So, and if it is direct impact, then by default you have to follow the full approach. Then installation qualification. After all this, we have go for the IQ. So minimum checkpoints that your protocol or test plan of the IQ, that should be include the test parameter like brand, type, name, model as per the specification, deliverable, undamaged as specified. So you have to checklist in the your IQ. If it is not done in SAT, then you have the checklist in the IQ. So you verify the undamaged or as specified. Check the prior documentation for the completeness. Okay, all that test certificate, everything you have to verify the system P and ID, okay. Verify any system components defined in the protocol. Verify the system P and ID means you have to take the PID printouts, PID diagrams in your hand, and then as per the P and ID you have to uh, check every instrumentation, every gauge, everything where it is placed, okay, as per the P and ID. Suppose there is a one bulb, diaphragm bulb is showing in the PID as per ID number 1256, and it is not there in the actual position, or it is not there, they are missing. So you have to verify your P and ID as per the actual, what is the actual in system and what is in P and ID. Okay, so P and ID you have to verify the system components detail like IQ, OQ, like make, model, serial number, capacity, okay, everything you have to verify for the components. Then verify the utility connections. Utility should be qualified, connection should be there, ensure the required utility are appropriate, okay. Then go for the verification of the instrument connections with the field to PLC and PLC to field. Check the connection to the peripheral devices like printer, dew points, or any other gauges, indicator. Okay, that should be all the peripheral devices should be connected. Check the manual functionality of all switches, buttons that should be properly operated, like emergency switch or any functional buttons is there, any switch is there. You have to check the manual functionality that should be properly and smoothly operated. There is no damage of those components. Then verify the complete part list that has been filed in the maintenance record or engineering store. So components or spare part that comes with the equipments or compressed air system, that should be verified which type of part is coming, which what is the spare part, what is the recommended spare part list, that should be maintained by the engineering, and that should be verified in the store. Okay, installation of the equipment checked to the current engineering drawing and specification, that is also part of your installation qualification. Visual verification of parts that free from the physical defects like scoring, roughness, dent, pitting, scratch, crack, decoloration, rusting, that all should be free from any physical defect. Collection of the supplier operations, working instruction and maintenance manuals. Okay, identification of critical instruments for the calibration requirement. What is the instrument like pressure gauge, Magnelli gauge, or pressure dew points, or RH temperature thermometers, whatever the instrument is associated with that equipment, that you have to identify make, model, range, location, okay, and capacity, accuracy, everything you have to verify or identified, and then it will be recorded in the IQ test plan. Okay, and same will be go to the engineering department. They will prepare the list and plan and schedule for the calibration. Before going for the operation qualification, you have to calibrated all the instrument. Then verification of material of construction, ensure that the machine installed in its designated place. So as per the GA diagram, the instrument or equipment location diagram, that should be properly placed. There should be a proper space for the maintenance or preventive maintenance, breakdown handling activity. Okay, verification of the material of construction, that the certificate should be present at the time of verification. Okay, all components should be verified for the material of construction. Then documentations, what are the documentation required? Measure the dimension wherever the possible. Documentation used for the IQ, you have to check as per the user requirement specification what are the document we are asking, like operation maintenance manual, electrical diagram, spare part list, process utility diagram, installation order of components, then utility connection, electrical connection, installation layout, documentation support specifically quality of parts, material of construction, test certificate. All these are verified in the IQ. Now operation qualification. So operation qualification basically a documented verification that the facility, system, equipment as installed and modified or perform as intended throughout the anticipated operating range. Critical functions such as interlock, alarms, counter, timers, detector, basic sequence, fault detection, handling, accuracy, integrity of collected data, reported operations of the human interface, panels, HMI, SCADA, okay, all operate as intended. So we have to check every functions in the operation qualification. Okay, so minimum requirements of the your protocol that should be contained: availability of draft SOP, calibration certificate of identified instrument, verification of the startup of the and shutdown of the equipments as per the operating manual or SOP operation. So draft SOP for cleaning, maintenance and operation should be available. Any other SOP for the data backup, okay, if it is 21 SCADA system or 21 CFR part 11 system, then data backup, alarm handling, okay, audit trail verification, every SOP that will be associated with this equipment or SCADA system, that should be available in the draft stage, at least in draft stage. Okay, verification of the operation of the equipment as per the SOP or that mentioned in the functional design, verification of equipment suitability within the operational range of the functional parameters. So in operation qualification, we have to cover the maximum possible operating range. Okay, and in PQ it will be less than this anticipated range or operational range. If we are doing the operation qualification with minimum range and PQ with the maximum range, that will be wrong. So operation qualification, you have to cover the maximum possible range, and PQ will be performed within that range. Verification of automated control system. Okay, when we have the GXP system, then we go for the verification of SCADA system, alarms, interlock verification, input output, PLC HMI verification, communication verification, security access verification, backup, recovery, power failure and communication failure challenge test that will be done, testing for the data integrity, verification of the configurable parameter and range testing that will be a part of your operation qualification. Then verification of specific function of the major component individually or as a unit. If there is any specific function for that component, you have to verify that operations of that component. Then verification of the upper and lower limits of the operational parameter. What is the maximum limit? What is the minimum range? Okay, that should be verified. Prepare the SOP for the operation, cleaning and preventive maintenance are adequate. So your SOP that we are drafted, that we have to challenge the operation of the equipment is handled through the draft SOP, cleaning, preventive maintenance, breakdown handling. Okay, so that we know that this SOP is able to perform the task or easily understandable. If there is any amendment in the SOP, we can do in the draft stage, and then final draft will be prepared before going for the PQ. The SOP should be effective. Then in performance qualification, that is the documented verification that system, equipment, environment support the system to produce the required output. For PQ, basically we have to perform the test that will be mentioned in our requirement, that will mention our user requirement specification as per the established standard operating procedure. Okay, then purpose of PQ is provide the document evidence that an integrated system is capable of performing the consistently to give an outcomes to meet the predetermined specification. So in PQ we have to challenge the integrated system, not individual units. We have to run the equipment from the generation to the distribution. Okay, so we know that our integrated system is performed as per the intended work. Okay, so performance qualification of the compressed air system, we have to mention minimum. These are the test requirement as per the ISO 8573 part 1 to 10, part 10. As per this guideline, there is a 10 parts, part 1 to part 10, that is published in 2010, or we can go for the ISP guideline for the process gases that is published in 2011. Okay, these are the some tests that is mentioned. So basic guidelines for the compressed air system is ISO 8573. Okay, so these are the some tests that should be evaluated in your protocol, that should be a part of your test plan, PQ test plan. Description, dew point, water contents, oil vapor, non-viable particle count, viable particle count, then gaseous test like carbon dioxide, okay, carbon monoxide, uh, sulfur dioxide, nitrous oxide. These are the some gaseous tests that can be do for the challenge the system. Okay, dew point, we have the classification 0, 1, 2, 3 to 6. So class 1 compressed air having the minus 70 degrees Celsius, minus 40, minus 20, plus 3, plus 7 and plus 10. These are the pressure dew point limits for the classification of it. So what is our requirements? Like suppose we have required the class 2 air, so the dew point should not be less than minus 40, means it should not be minus 39, it can be minus 40, minus 41, minus 50. Okay, then concentration of liquid, if it is going for the 7, 8, 9, then we have to verify the concentration of liquid like 0.5 gram per meter cube, like 500 mg or more than 500 mg. Okay, that is the requirement for the higher class 7, 8, 9, 10. Then these are digital dew point meter that is installed in the pipeline, so it continuously or dynamically give the actual result of the compressed air quality, what is the dew point is going on. For the performance qualification, we can use the gastric tubes for the water vapors, Okay, we can use the gas tech tube of two models like 6AG or 6A. There is a difference in the range. So which type of range we require for the determination of water contents that we can use. So different gas type of gas tech tubes available in the market, so you can use accordingly. Range like 6AG, it will be a higher range, 100 to 3000 and mg per meter cube, or this is the 6AG, that is the 20 to 80 mg per meter cube. This is the range difference. So sampling volume is already defined in the manuals of this gas tech tubes. So you are using the fresh air tube. So from this side we have to connect it with the kit, and it will change the color from like this, from the pale yellow to bluish, green to purple, sorry. This is the green color, and this will change into the purple, and this is the scale for up to which it will be changed the color. That will be your reading. Sampling rate is 300 ml per minute, and sample for 1 minute. In 1 minute, what is the color change you are seeing directly on the scale? That is your value, okay, for the water vapors. Similarly, this also comes for the uh, another one. This is the two type of gastric tube, 6A and 6AG. Okay, then oil vapors. This is also class 0, 1, 2, 3, 4, and X. So if you are using the class 2 here, then it will be should be less than 0.1 mg per meter cube. For that purpose, we are using the direct indication tube, that is called the 109 AD, that is the gastric tube used for the detection of oil vapor. So minimum sampling rate 1000 ml per minute. For the 20 minutes we have to purge the air inside this, and it will change the color from the pale red to pale blue. So we have directly read the readings in on the scale. So that will be your value. This is the gastric tube that change the color. Okay, this is the time parameter. If your range is 0.1 to 0.2 mg per meter cube, then you have to sample for the 40 minutes. If you have the range 0.2 to 5 mg per meter cube, then you have to sample for the 20 minutes. This is the criteria for the oil vapors. So you can directly measure the oil vapors. Now, non-viable particle counts. For that purpose, we are using laser-based particle counter ranging from the 0.1 to 5 microns. So 0.1 to 0.5, zero point 0.5 to 1, and 1 to 5 microns. So this is the range that is as per the classification. This is a 4 lakh 6,000 and 100. These are the particle concentration that should not be exceed at the user point. Okay, so this is the criteria for the non-viable particle count. Viable particle count, that also be done through the air sampling. Air sampler, we have to place the arrangement over this head, so that the air will be passed through this head, and that will be direct contact with the media plates, and then the particles settle on this media plate, that will be incubated and will give the result for the viable particle count in that points. Okay, carbon dioxide that we are using 2A. Okay, this is the tube number for the carbon dioxide, and then color change will be yellowish orange to yellow. Okay, the sampling time is 5 minutes, and measuring range is 250 to 3000. So carbon dioxide, as per the ISO, it will be should not be more than 500 mg, sorry, ppm. Okay, so 250 to 3000 we can use this tube 2A for the determination of the carbon dioxide in the airstream. Then carbon monoxide 1LC we can use, that will be change the color white to pale pink if it is detected the like this, if it is detected the carbon dioxide in the compressed air. Then sulfur dioxide, that we can use the 5LC tube. Okay, SO2, that will be change the color bluish purple to the white. Okay, this is the actual tube, and then break this tube from the both end, and then connect it to the gas tech pump, or with the compressed air test kit for, which is having the rotameter to control the flow of the air, and then we have to connect this tube from this side and pass the air. Okay, so the measuring range is 0.5 to 0.25, 0.25 to 10, and 10 to 22. So this 5LC is coming in the 3 range. So which one is you want to use, or as per your protocol that we can use, and the sampling time also different for the different 8 minutes, 4 minutes, and 2 minutes. Okay, the sampling volume 100 ml per minutes. Okay, or 400 ml, 200 ml, or 100 ml. Okay, that is the criteria for this sulfur dioxide. Then nitrogen oxide, NO, NO2, that will be use gastric tube 11L. Okay, and the color change white to yellowish orange when we are using this tube. So it will look like this, yellowish orange. White is this, and this is the used one. So up to which it is color change, that we can directly read. If there is no color change, means not detected. There is no traces of the nitrogen oxide. So performance qualification, when you perform this all these tests, you have to prepare the summary report for the performance qualification. Your summary report should clearly indicate what is the capacity of the equipments, what is the range, what is the recommended operating parameter, that is from the uh, performance qualification, what are the recommended parameter you are going to for the routine qualification or routine use. That all three things should be mentioned in your summary report. That will be your conclusion or recommendation in the summary report. Then you have to generate the equipment handover certificate, and all qualified equipment to be hand over to the user department after completion of the performance qualification. So this is all about the compressed air system, how you are going to qualify the compressed air system. Okay, we have discussed every perspective of the compressed air system. Thank you for watching, and our next training video on the cleaning validation. So don't forget to subscribe and like the channel to get the updates. Thank you very much.